I'm Frank Wardynski, Extension Educator with Michigan State University. I'm housed in Ontonagon, which is in the western end of the Upper Peninsula, and today we're in Chatham, Michigan at the Upper Peninsula Research and Extension Center, which is located in the central Upper Peninsula. Today I'm going to be talking about taking samples from dry hay and Baleage bales. When we're going to take samples, the nutrients that we're going to test for, and then the sampling procedure. We're going to look at two different times to sample hay. One is at harvest or storage, and the other one is at feeding time. At storage, we're primarily going to be concerned about dry matter content and the weight of the bales so that we have an inventory of the hay going into storage to give us an idea to make sure that we have enough hay to go through the winter time. And at feeding time, we're going to want to take that sample as close to feeding as we possibly can, because we're going to test that one for nutrient content, crude protein, acid detergent fiber, neutral detergent fiber, relative forage value, relative feed quality. And those are indicators of the quality of the feed that we'll be feeding to the animals. We can use those indicators to indicate what type of class we should be feeding that to, and whether or not we have a good enough quality feed to meet the nutrient requirements of the animal. If at the time of harvest and storage, the only thing that we're really concerned about is the dry matter content and the bale weight, so we understand how much dry matter is contained inside of each bale. We can do that on the farm without sending it in and paying for an analysis. Here we have a Koster tester, the heating unit here that we would just plug into an electrical outlet. Here we have the portion where we would put the sample in a scale. We would weigh the sample with moisture in, the wet sample, even if it's dry hay, I call it a wet sample. We'd put it on here, we would cook the moisture out of it. We make sure we pay special attention that we don't overcook it when we start destroying organic matter. And then we'd come back on here when we have a perfectly dry sample and weigh that. We'd do the math and we'd be able to calculate what the dry matter content of that forage is, do the math with the bale weight, we'd be able to understand and know what the dry matter, total weight of dry matter in each bale would be. At storage, we can also test for crude protein. It gives us a rough estimate of the quality of the feed that we're actually harvesting without going through the expense of testing for all of the nutrients at that point. After storage, before feeding to test for crude protein, if we have thoughts that there's problems with regards to heat damaged protein, we're also going to want to test that so we can take that into account for feeding. The fiber fraction, ADF and NDF analysis will give us an indicate in terms of intake of the animals and how much dry matter intake they're going to be able to consume, and relative forage quality. The relative feed value and the relative forage quality are indexes that give us an idea of the overall quality of the feed and how it compares to average forages. We can also use it to indicate what livestock that we should feed it to with regards to animals that require higher quality feed. I'm going to talk about the various types of forages and drills that we're going to use to collect the samples with. Here's a big heavy-duty forage probe that we can use to take multiple samples before we empty it out into the sample bag. This one's powered by a high-powered half horsepower drill. I really like it from the standpoint that here at the chuck we can tighten it down good so we don't have to worry about it loosening and falling off or spinning on the probe. Here we have a smaller probe. Certainly the diameter here is smaller, goes into the bale a little bit easier. We got a big canister here to push sample down so we can take multiple samples at a time. This one here I have attached to a battery powered drill, a drill that one is difficult to get tight compared to the one with a chuck. So we're going to have to be careful that we get it tight enough. It can spin, sometimes bruise some knuckles, things of that nature. Certainly don't have the same level of power. Holding onto this can be more difficult without having the handle on the one side as we use that for collecting samples. And then finally, here's one that certainly is very functional but doesn't have some of the features that the other probes that we have here. We'd attach this onto a drill just like the other ones. It's a bit of an older style that it's going to go in. We're basically only going to be able to take one sample at a time before we have to take this off, empty the sample into a container to hold that. Regardless of the type of the probe that you have, one of the things that's important is to make sure that we have a good, aggressive, and sharp tip so that we can cut through and penetrate in through the bale. When we're sampling large round bales, it's important that we go from the side and in close to the center as we possibly can, from, in this case, top to bottom, as these are stacked on end. That we're going to try to hit the center of the bale, and we're going to go straight in to get that forage probe. Another consideration with large round bales is that they're not always stored inside like this. And so if you're stored outside or have other reasons that you have some kind of storage waste on the outside, we want to make sure that we get through that part, because much of that damaged material on the outside isn't going to be consumed by the cows. So we want to get in there and get the good forage sample out of the hay that the cows are actually going to eat. I found that it's important after taking each probe to use the stick or the ram to drive the forage down into the container. It's possible to take 2 or 3, but at some point it gets so tight in here that you're not able to do that without using great force. And then there's a safety procedure I wanted to talk about, is that we want to make sure that we use great care in making sure that we don't ram it down and then you ram our fingers or back of the hand down into the probe. I've already talked about the importance of having a sharp probe. We'll certainly understand that if we break through and jam it down in there, it could cause some physical damage to the hand. I'm also going to talk about taking samples out of small square bales. Here's a small square bale. This is a straw bale, but it certainly worked for our purposes. You see it's on end. You see the strut twine coming across here, and here's the end. We want to take the sample from the end and in the middle. And we want to make sure we're not too far to one side. If you're baling hay, leaves will tend to accumulate in the bottom half of the bale as it's coming through the bale chamber. So one side of the bale will be a little higher quality than other. So we want to make sure that we're right in the middle of that square bale. If we were doing large square bales, the procedure would still be the same. We would want to make sure we use visual inspection and make sure that the bale's uniform, make sure that the bale doesn't have some kind of deterioration or some reason that would give us a bad sample. But we're basically going to go in from the end, and we're going to go into the middle of the bale. I also need to talk about the number of samples we should take. We should take a large relative sampling so that we're not just going to sample 1 or 2 bales. We're going to take in the range of 10 to 20 bales or 10 to 20% of the bales that we're going to sample. If I were going to test 100 bales in a day, then I'd be looking for that 10 to 20 number. If I were only going to have, say, a lot of 30 bales in there, I still want to do about 10 bales of that sample lot for nutrient analysis to make sure that we got a good representative sample that we'd send in for analysis.